Well, good afternoon, everybody. Thank you for coming along and being prepared to listen to me about CPVC pipes and fire protection and the lessons learned. So this is Global's experience of dealing with CPVC pipes, which I'll come on to in a minute. We're Global. We're at the stand just here. We're a national active fire protection and passive fire protection specialist, and we also have a fire safety engineering consultancy division called Global Technical Services. We've got about 600 engineers working nationally in either active protection or passive or in consultancy works. Obviously we offer qualified fire engineering support through our team, of which we're headed up by a guy called Ross O'Loughlin, and we have 3 fire engineers to support the business and our clients. Global offer a complete approach, both active and passive fire protection and fire engineering support, which some of our clients choose to take all those services or select just an element of them moving forward. But today I'm here to talk about CPVC pipes. So what's a CPVC pipe? That is a CPVC pipe, which is a sprinkler pipe. It came out of a block of flats in Reading. We removed over 1,000 1-metre sections of pipe. Why did we remove that pipe? So what's wrong with that photo? I took this off LinkedIn a couple of weeks ago. Some guy thought he was doing the right thing. It's fire stopping a CPVC sprinkler pipe. Prior to applying the firestop seal, he's applied some tape, some mastic tape to the pipe. He was then going to apply a seal. That's a major fault. There's a compatibility issue between the pipe and the adhesives on the plastic pipe, on the CPVC pipe. Consequences of that are that it could soften the pipe. The pipe's at 13 bar pressure, it ranges between 9 and 13. If you soften that pipe and you put the pipe under undue stress, the pipe will burst at 13 bar pressure and cause quite serious damage to the structure. We know this from personal experience. So, case study. Back in 2013, Global had won a contract to actually remediate 40 odd hotels across the country. All of them had been fitted with CPVC-based sprinkler systems. It was a multi-million-pound contract for us. We started work on a site in the north of England, and on the first day, we're working on a roof space, and we had a major incident with these pipes bursting. This particular client was very progressive and is very progressive. So installing sprinklers is a wonderful thing, and we should all be doing it. But we need to be aware of the risks and hazards associated with the pipes, particularly in relation to installation, fire stopping and maintenance around the pipes. The first install in the UK was in 1998 at Marble Arch. The product had been brought over from the US and installed on an American brand standard that had been rolled out across this chain of hotels. That install was completed around about 2004. Off the back of that, we were commissioned to survey all the sites, identify the underlying fire stop issues and remediate. At the time, we didn't appreciate the risks involved with the pipes. Very few buildings had them fitted in the UK. So we were working in a particular hotel. The priority of this for the client obviously was safety of their customers, and they have a motto that every single bed is protected by a sprinkler system, which is obviously a good thing to have. CPVC pipe, what does it stand for? The C stands for chlorination, so it's a chlorinated PVC. It was used extensively in the US for about 30 years. Benefits, it's cost effective, it's quick to install, it's easy to train the guys on how to install it. There's a reduced skill level, it's cleaner to install than traditional systems. There's a lifespan of 50 years, plus or minus 2 years, and it's very low maintenance once it's installed, if it's installed correctly. Our 2014 incident was a CPVC pipe in a roof space. We were installing a rock wool fire barrier at the head of a block wall. This pipe was located at the base of the wall. The pipe was pressurised to between 9 and 13 bar. It was a 40mm pipe. As one of my guys put the ladder against the wall, the block wall flexed. Unbeknown to us, the pipe was cross-contaminated at the base. The pipe is fixed to a wall with toggle clips. Those toggle clips are supposed to be such that these pipes have a little bit of flex and movement in them. So it didn't have that. Once we stretched the wall, we had a stress point on the pipe burst, it took the wall out, took the floor out, and it took out the 3 floors below. Caused over £1 million worth of damage to this particular hotel. It's significant. Hotel was shut down for 5-6 weeks. If you've come across burst pipes with CPVC, you'll be very aware of it. So investigation and cross-contamination on the pipe was a major learning from that experience. Challenge for me was obviously to resolve that immediate crisis that I had, but also then to secure the work moving forward on the remaining 40 hotels that we need to remediate. How would we work on these pipes, and how would we fire stop the seals on fire line wall details? At the time in the UK, there was very, very little guidance on these pipes. Around about 2013-14, raised this with the ASFP, the IFE at the time, there was no information. So you can see the resulting damage on the photos there. Literally people's belongings were floating down the corridor, which now is amusing. At the time it wasn't. So what are the cross-contamination issues? Painted pipes should be an amber flag issue for us. PU foams, amber flag issue. Corks and mastics, particularly silicon-based mastics, because the plasticizers in the product soften the pipes. Hydrocarbons, installing these in kitchens and not having them enclosed is a fatal error. General debris and dirt, if we put them in roof spaces and run them along the walkways, we trample across the top of them, you'll cross-contaminate the pipe with all sorts of debris, and it'll cause long-term damage. Kitchen oils and edible oils. This came up as a question. It's a red flag item. So again, if we put them in kitchens, high risk of potential cross-contamination and damage to the pipe. You can see a photo there of a pipe that's become damaged. So I pass around the example here. You'll see that this one's been cross-contaminated with a cork in. You'll see that it's reacted with the pipe and it's caused the pipe to expand and swell. It may do that. It doesn't necessarily mean it's going to burst. It's got to also be under the undue stress and pressure that the pipe's on through flex. Then it'll burst. So plasticizers change the composition of the pipe, so the pipe's hygroscopic in its nature. Fire stop products, particularly silicon, must be avoided. So at the time of my incident in 2014, there was no manufacturers in the UK that had test data to support their fire stop products on this pipe. So I went off to Hilti, big conversations with Alistair Brockett, their technical fire director. He supported me in relation to finding some details from the US. They were imported into the UK, and that was our solution that we applied at the time to this chain of hotels. Since then, various product manufacturers such as FSI and Quellfire have actually tested their products in relation to this piping system, and now we can say that there's probably about 4 manufacturers that are approved for install with these pipes, but we've still got to be very careful about how we remediate the pipes and how we fire stop them. So fire stop products, silicon must not generally be avoided. Fire-rated PU foams and builder's foams avoided. Fire-rated paints or paints in general should be avoided. Fixing points. When the guys do the install with the toggle clips, the pipe should be designed such that it's got some movement. The guys will go off and get a cheaper version of the clip that might have a rubber banding in it. That rubber will react with the pipe, potentially soften it and cause a burst. Since 2014, then, several manufacturers have now got type approval. So the situation's actually improved significantly. The FPA and ASFP have released guidance notes which are available on their websites in support of the test details that are available. So the lessons learned. How do we fire stop the pipes? In 2014, little information, little or no knowledge. Most clients are unaware of this risk. So today, audit many sites, come across situations where we think we've done the right thing, we've installed a sprinkler system, which is the right thing to do. However, it's not been fire stopped correctly, or they've cross-contaminated it. That pipe will fail at some point in its future. All installers should be making clients aware of this. They're not doing that generally. There's a compatibility site which has been developed since about 2017. It's an American site. If we go onto this site, it's a Lubrizol FBC system compatibility site. If we go onto that site, we'll click on products that are compliant and products that are high risk. On the high risk page, it will group and list different product types. You'll then click into the manufacturer details and it will give a risk rating. And those risk ratings range from 1 to 4. Obviously, the higher level the risk rating, the more risk of cross-contamination damage to the pipe. It will range anything on that site. It will list firestop products, pesticides, paints, cooking materials, all manner of things that will react with the pipe. Additionally, on that site, there'll be another link that you can go to for Europe, which will list all the product manufacturers that can be used with the pipe. Obviously, if we choose to deviate from that and that approved list, and we have a serious incident and a burst and a significant claim, you'll have invalidated the warranty from the pipe manufacturer, so you'll have a serious situation in recovering costs, in addition to not having the supporting test data from the firestop manufacturer to underpin that claim. So little knowledge awareness in the UK, that's why I'm trying to highlight it. Use of non-approved products should be avoided. Designers, installers must check compatibility prior to the build. Early engagement is crucial. So it's not so simple as just installing the piping system. We've got to look at how it's remediated in the wall lines that it's actually been installed in. The alternative to that is to submit the product for testing. So if you have a product that you want to apply against the pipe in a wall detail, you should submit that to Lubrizol for type approval. You then become approved and are listed on their individual particular site. The other thing to consider is emergency procedures. When I had my burst pipe, what made the situation worse was that we didn't have the isolation key for turning off the system. The engineering team on site, key engineering manager, had the key that was controlling the chain that was through the isolation valve. He wasn't there. We couldn't turn off the system. It took 20-30 minutes to break the chain. That's pumping out at 13 bar pressure. We flooded the swimming pool. It was that bad. So know the emergency procedures in relation to working on these systems. I think it's sort of vital that we depressurize the system before working adjacent to them. The 13 bar pipe goes off, it will take walls out, it will potentially cause a fatality. It's often not done because most engineering managers or maintenance guys at site are reluctant to drain down a system or depressurize it, because you get a vibration effect when you pressurize the system and depressurize them, and they're worried about the systems going off and breaching. But it's vital that is depressurized. It's also important that any contractors working in roof spaces or areas where they're given the do's and don'ts about working around the pipes. That often never happens. So ideally, permit to work system in place for draining down the systems and depressurizing them. Pressure testing of the system, if we're recharging it, must be a wet test system only, not using compressed air. The systems are normally tested to 12 to 14 bar on site, 60 bar in a factory, 113 bar is the burst pressure of the pipe. The pipe is very robust. You can hit it with an hammer, drive over it with your car, it'll have little impact. Cross-contaminate it with the wrong materials, and you will have major failures in the pipe. So key message, design specification on fire stopping should be at design stage with a CPVC pipe. We should ensure that we've got supporting test data from the manufacturers before installing the systems. Early engagement on fire design that links them with the fire strategy, and the product specification for the actual fire stop materials that we're proposing to use with the pipe. Supporting standard details and EJs from manufacturers in support of the test details. Maintenance and drain down procedures must be sort of enforced with any particular site that we're looking to put these systems in, and I think we need a program of awareness for the contractors working in and around these systems. Thank you. Any questions? Short and brief. And can I have my pipe back? Ben, no.
Hi, Andrew. Ben Freeman. Chlorinated polyvinyl chloride, some manufacturers who aren't on the compatibility website is, being proven as being compatible, have suggested the use of tin foil surrounding the pipe as a barrier between the intermeshing which is used. Is that acceptable? And if not, why?
In my opinion, it's not acceptable because you're invalidating the warranty on the original CPVC pipe. The manufacturer wouldn't support it if it burst in the event of us having a leak. So, and also we've not got supporting test data, unless you can prove me wrong, for that scenario. The system may work, but if they're confident about it, go off and test it. Do you agree? Yeah. We come across that all the time, yeah. Another option is to sleeve the pipe with another orange pipe, which again is a non-approved approach.
Afternoon.
Hello.
CPVC pipes are not restricted to sprinklers, are they?
No, there's alternative and other types of PVC, which have the same issues.
Okay.
Yeah. But with all plastic pipes, we need to check compatibility against manufacturers' data. But CPVC in particular, myself, Chris, Ben, we're aware of many projects where we've had major leaks and bursts, and they've caused £1 million plus damage to buildings, far greater than the fire would have been, to be honest.